of PyCon Hong Kong. I am Sammy Fong, the conference chair of PyCon Hong Kong. Hong Kong is an international city in Asia. A lot of travelers around the world visit and transit in Hong Kong. 10 years ago, we have the first Python user group meetup. And after I visited PyCon APAC in Tokyo, I plan to organize PyCon Hong Kong, and we started from 2015. 35% of our speakers comes from other countries in Asia, Europe, and America. We are not just a local PyCon in the city, and it is also for the global and Asia Python community. We have about 200 participants every year. This year in November, we will organize the second online PyCon Hong Kong, and we are now calling for proposals. And you can check out the CFP details at the website pycon.hk. I hope you can submit your proposals to us and join our conference. We will also encourage our participants to make the donation to the PSF. And stay safe. And I hope we can meet you soon in PyCon. Thank you.
Microsoft is delighted to be at PyCon. Hope you are enjoying the sessions. Scan the QR code to join the Microsoft developer community and receive regular updates on many open source topics, including Python.
Hello, fellow Pythonistas, and good day from Sabah, Malaysia. Welcome to PyCon APAC 2020. Today, we're going to be talking about patterns for the future, and it's going to be a really diverse topic that covers many aspects of the language we all know and love, sometimes hate, but mostly know and love. Our panelists, as you can see, are very experienced in open source, governance, data, robotics. I also saw something about amateur rocketry. So in case there are some questions about that, hey, everything goes in this show. So we've got machine learning, so much more. So viewers, by the way, do not hesitate to ask questions or provide your commentary on our live streams. So I'm Arthur Raymond, and I'm the moderator for this session, and I'm streaming live from North Borneo. Isn't the internet wonderful? So we are honored today to have several esteemed panelists joining us for this forum. So thank you for joining us today, panelists. I'll do a few short bios first, but don't worry, there's a much longer introduction after that. In no particular order of preference, like pre-3.7 dictionaries in Python. So we have Carol Willing. So Carol Willing, right over here, she's a core developer for Jupyter Hub, Binder, C Python, and a leading member of PyLadies San Diego. Did I get that right? San Diego?
Absolutely. So, hi, everyone.
And then we have Audrey Filroy, and she's a creative experimenter and maker. Django Cookie Cutter dev. So for those who are hearing Cookie Cutter for the first time, that's a framework for jump-starting production-ready Django projects. I got that right off GitHub. I'm more of a Flash person, but hey. And also involved with PyLadies Los Angeles, if I'm not mistaken.
Well, there's Cookie Cutter and there's Cookie Cutter Django. Cookie Cutter doesn't require Django at all, and it's used by not just Python projects, but JavaScript, C, R, you name it.
Oh, that's awesome. This is something that I need to check at a later point as well. And of course, last but not least, we have Keith Packard. And Keith Packard sits on the Xorg Foundation board and is also involved in educational robotics and, as I read off the bio too, amateur rocketry. And I guess Keith, he started the Snack language project. So that's a language based on Python for running on embedded systems, basically systems with less than 32 kilobytes of RAM. So we like to thank our panelists for taking the time out of their schedules today to join us on a Saturday evening. So a good evening once again to everyone.
Thank you for having us.
Indeed. So what does the future hold for the language and its many forms and applications? What can we put into practice now and focus on right now to make a better future? Folks, viewers, everybody, let's find out. So let's get the ball rolling, and we'll start with the longer introductions. So my question first, to get the ball rolling, would be perhaps your favorite pet project, a little bit of introduction about yourself, and maybe your pet project or an experience that you had. Some people call it a war story that might interest you or that caught your attention over time. So maybe I'll begin first with, let's see now, I don't have a random coin flip. So I'll start first with whoever's like at the top right corner of my screen, and that would be Carol Willing. So Carol Willing, a little bit about yourself and your pet project.
Right. So I'm Carol Willing. I work on the Jupyter project as well as Core Python. Some of you I had the pleasure and honor of meeting last year in person. So I'm really, really glad to be back again. I had an absolutely wonderful time. And I think some of what's best to come with Python is actually in your own backyard. And I think, I have a couple pet projects. Clearly, mybinder.org and the Jupyter projects are really important. But I also, I really like Dataset by Simon Willison, and also FastAI and NBDev, which is also by FastAI. And that lets you pretty much do everything, add your documentation to notebooks. And my war story is Audrey Feldroy got to convinced me to be on the Python Software Foundation board. So I owe most of what has happened since to her.
Aw.
Thank you very much, Carol. So now on to the next person. Audrey, what's your pet project war story?
My name is Audrey. The big projects I've been working on lately have been 2 Scoops of Django 3.x, the book, and also a Wedge of Django, which is a Django tutorial book. And one of my pet projects is playing around with the Inkscape Python extension. And for example, actually, wait, no, this isn't quite. I just remember that that's not Python. This is using L Systems, a different extension. But anyway, one of my other pet projects is just experimenting a ton with installing random Python tools and frameworks. And I noticed one day that my my hard drive was just filling up, and I couldn't figure out why. And it, normally virtual envs take up maybe a few megabytes, if that even. Python code is small, but I discovered that I had been installing so many Python packages that I had gigabytes of virtual envs just filling up my computer. And so I had to go in and delete all of them. So that was a war story.
Thank you so much, Audrey. So last but not least, so Keith, what would be your pet project and your favorite war story?
Well, I have a lot of pet projects. The pet project most closely related to Python these days is probably the teaching that I do, trying to teach students programming. I tried to teach 10-year-old students how to program in C for 5 years, and I finally gave up and decided to try to teach them Python. And the first year I taught them, one of the students came up to me and said, "I love programming." And that was a fantastic tribute to Python. We hate programming in C till we love programming in Python. That was fantastic. So the pet project that we built last year was our little SNEC board, an embedded microcontroller designed to control Legos with Python. So you can do Lego robotics in Python directly, and that's been a lot of fun. Probably my most recent Python war story was another 2 to 3 conversion. I have a calendar application called Calypso, which manages my calendar data. And it was stuck in Python 2 purgatory for about 2 years because some of its critical dependencies had not been migrated. And so I dug down and converted some of the dependencies and got it moved to Python 3 last year. That was so exciting. So I am no longer dependent upon Python 2 for any of my daily work.
Thank you so much, Keith. So now we have a little bit view. We have a really diverse amount of projects that we're running here. So this is something that I'm going to throw to everybody, but feel free to go first if you like. Do you see where you're heading to in terms where your projects are heading to? Perhaps maybe like in the case of embedded programming on your side, the SNEC board. From my point of view, when you talk about training with students, my own organization, actually, we tend to do a lot of Raspberry Pi. And yes, our students also love Python. The teachers love Python. It's something you can teach them in 2-3 hours, and they get it. They know how to use Turtle. So the idea here is when we talk about, let's say, SNEC, for example, where do you see that going? Will it like reach that sort of critical mass, for example, in schools with Lego and so on? And then beyond that, do you see anything going there, Keith?
I don't really know. I teach a class of 10 to 15 students every year for a year-long class in robotics and programming. And we have used a huge range of languages from Logo. I don't know if any of you remember the Logo programming language. Carol is of a generation to remember that as well. But when our Apple II computers died and we tried to start using Arduinos instead in C, we couldn't get the 10-year-old students to learn how to use the keyboard effectively with that language. And the transition to Python has been revelatory. And so I'm very excited about teaching students how to program in Python. SNEC offers a very, very gentle introduction, but the same hardware that we use to program in SNEC can also be used with MicroPython or CircuitPython, which is a great step up. And the whole notion of doing embedded programming in languages like Python that are so much more approachable to students is a fantastic opportunity. Raspberry Pi is a great environment, but it's very hard to control robots with Raspberry Pi. That's great for web serving and media systems and games. But the ability to program robots and transition students from building Lego models to building Lego robots is a great way of getting them into programming from a different activity that's related. And so robots need embedded programming environments, and we've got two great examples. I'm hoping to be able to use both of them in the future. It's fantastic.
So I was just looking down at the comments as well, Keith, and I see a lot of people, not a lot of people, but there are people saying turtle, and then somebody said, why turtle? But yeah, turtles, a turtle logo, everything is a great way to get people started because there's like cause and effect. You do something on the computer, something actually happens, well, say in the real world last time, but now it draws a line on screen. So since you're on this topic of education, and this is definitely one of the patterns for the future, Python in education, this is a question that I can open to both our Pi ladies as well, because you are also in the communities. Not necessarily Pi ladies itself, but like the projects that you do. For example, Jupyter, definitely. I mean, a lot of academics end up using Jupyter, as well as Django itself. That one would be more to the web developers and so on. Where do you see your frameworks going to in the near future as well? And perhaps maybe how do you do that education in your respective organizations as well? And perhaps there'll be something fascinating on that side as well. Perhaps we can begin first with Audrey.
Sure. So Django is a web framework that was created in 2003, and at this point it is so mature and so stable. I recently upgraded this one legacy Django project from 1.11 to modern Django 3, and I thought it was going to be very, very stressful and painful, and I actually finished it in about a week. And that is a testament to how just how stable and reliable Django is, that even if you upgrade, they have figured out the upgrade path. And not only that, it's also moving slower. So it's so, you know, over the next 1 to 3 years, I see it evolving from being the new, I mean, it was the new framework all the cool kids were trying. Now it's the mature framework that enterprises feel comfortable adopting, governments, just established organizations, and the need for just modern evolution of it is happening more through the third-party package ecosystem, through Django REST framework that a lot of companies have adopted single-page app patterns for their web applications. Django has experimental async support, but it's still very experimental. I see it over the next 1 to 3 years becoming much more stable and widely used.
Okay, just as an aside as well, to draw in the education aspect of this, this is an extra question that I like to tack on. Do you see, do you use in your organization actually a Django-based project, let's say, to do outreach and so on, training or otherwise, getting materials out, for example? Or do you rely on pre-made, there's a point to this question, which I shall raise later, but I was wondering whether you use custom-built Django apps for education and outreach. Just curious.
Custom-built? Well,
yeah.
Well, so my husband Daniel and I do a lot of training. We've done corporate training in the past, and lately we've gotten into virtual online training with Django, and we actually use our book, A Wedge of Django. This used to be our corporate training materials, and it's a walkthrough of how to build a modern Django project from the ground up. I don't know if that answers the question.
I think it does, actually. So the way, because now that we're on this, we're still on framework, so I'm trying to like bring all the frameworks together right now. So I would like to hand this off, the next question, to Carol as well. So Carol, being by virtue also that you're a member of the Python board, the Python Foundation as well, how do you see the things that you do, like Jupyter Hub, MyBinder, and so on, help promote that sort of outreach and the education side as well? And this one is more like developer education and so on.
Right. So I think something that's really unique about the Python community in general is you will run across many people that have a strong passion for education, and in particular, sharing their knowledge so that others can learn from that knowledge. And I think it was 2014, Audrey and I and others in San Diego taught an intro to Python class using what was then the IPython notebooks, which was the name before it became Jupyter. And I actually have used those notebooks in the 6 years since to teach beginners how to learn Python. And they still work. And one of the really nice things is, since we've built Jupyter Hub, and then my Jupyter Hub gives notebooks to everybody, and you don't have to install anything locally. You just need a web browser. And MyBinder is actually an ephemeral service. So you can go to a GitHub repo, and there might be a little button, launch on Binder, and you can have your own environment with everything pre-installed. So it actually works really well for teaching people. And interestingly enough, one of the current PEPs, which is Python enhancement proposals for the Python language itself, Guido and others put together a binder to demonstrate how this potential new feature in Python might actually work in practice. And one of the things we've tried to do as we add new features to Python is really think about how folks can teach it. And I think it's super important, because I think one of the things that's great about Python is the ability to get started and do meaningful work quickly. A lot of that is the readable syntax, but even more so, the many, many third-party libraries that there are out there, like the ones Keith and Audrey have already mentioned.
Thank you. So the reason why also about education here is this is an observation that our local communities notice on this end, and I guess this is part of the problems that we're facing, or the challenges that we're facing. We notice that right now there are lots of solutions that are being built that seem to be missing the fundamental glue of putting things together. Let me give you an example. For example, people talk about the Internet of Things, and we deal with a lot of Internet of Things stuff, and Python is like a good language for it. But let's say before that, people don't have necessary training how a network works. So they don't know what an IP address is. They just take a package, they take a library, they toss it inside the application, and heck, it works. The problem is they don't really get that fundamental glue that puts IoT together, which is actually stuff like basic networking. So the thing is, when just now, Carol mentioned also that they try and address the educational aspect of when they're thinking about a future PEP into Python. So the idea is, do you see this becoming a problem, and perhaps maybe you see a solution in your respective framework that can solve it? I think on Keith's side, that wouldn't be so much of a problem, because it's like pretty fundamental. You know, it's like you are at the board. But let's say like the Django, for example, or for that matter, many of the other packages, there's a level of abstraction that creates this issue. So I was wondering whether there would be a way, maybe somebody could suggest, or there is already a proposal in progress that can solve this problem of everything's too abstracted. So I hope that's a bit long, if you get what I mean. That level of abstraction. Is there anybody who would like to begin on this, or perhaps would like to comment about it? Audrey, do you have something?
Sure. Well, so in our classes, the way we get around. So the big hurdle is setup. That setting up a Django project is
DevOps.
normally it's very, very hard. I mean, sure, you run the start project command normally with Django, and then the hard part is adding all the dependencies and where do you put them and which requirements file, how do you break those up, and then if you want to get into the front end side, all the front end JavaScript dependencies, it is so hard to get someone up and running with all that. And our solution has been to create these project templates using Cookie Cutter, the project templating tool, and get students up and running with minimal configuration. So the they just point Cookie Cutter at the template they want to use, type in the name of their project, and run. That's our current solution. That said, I think that teaching is moving more and more toward in-browser education, and the less you have to install locally, the better, in my opinion, for teaching students. That I've started playing around with a tool called Anvil, which is it's a simplified full stack Python development framework, and under the hood it uses Sculpt, the in-browser implementation of Python and JavaScript, and you code your Python project entirely in the browser. You don't have to install anything. And I know that that's similar to the notebook experience and other experiences in browser. So I think in browser is one of the best ways to get students going with code.
So from an in-browser perspective, so I would ask from a browser perspective, perhaps this one I would ask to Keith. So does Snack currently, would it be going in this direction for in-browser? Because I noticed—
Oh, I want to. Now I want to do that. I had not even thought of that before. That's very exciting. Right now, you have to download a Python program called the Mu Editor to be able to control your device. It's a fairly low dependency Python application, but still, Audrey, I'm very interested in learning how to build a Python-based web app that can actually control my device over from a web server. That'd be fantastic.
That would be cool. I'm going to try out Snack after this and let you know if I have any ideas.
I've got the Anvil page open.
Cool.
Learn something new.
I was going to challenge both of you. So Jupyter Notebooks actually have these concept of a language kernel. And when CircuitPython first came out, I was kind of playing around with the notebooks and with CircuitPython, and I actually built a kernel that would support CircuitPython and allow you to control the board from the notebook. And, it was a weekend hack, and I've since given it to Adafruit to kind of do with it what they will, because it was open source. But I do see some linkages between the two. I think, Python and JavaScript together are a lovely combination because you get the best of the browser with the performance and structure and maturity of Python. And in particular, when I teach folks, whether they're adults or children, what I try and do is start them inside the browser with some really cool examples, whether it's, manipulating photos or art. And Audrey knows far more about that than I do. But once they realize the power of what they can do, then it's much easier to convince them to go through the process of installation. Whereas if you start with installation, I find it's much harder, because if it doesn't work right the first time, it's usually a nightmare. And, it sort of doesn't make a warm, welcoming experience. Whereas if you can give people some success early, then they're willing to work through the challenges later.
Thank you very much, Carol.
Mhm.
So the idea, so here's the idea on the table now. We will see perhaps in the future more in-browser operations of the, well, obviously we do already. Most things are web-based today, but we see more and more tight integration between the browser and even the low-level frameworks that we use. So carrying on from this idea with the in-browser perspective as well, we see that the frameworks that we work with, generally speaking, also tend to handle, to shift the topic a bit, tend to handle also some amount of data. So in this case, when we are doing terms like data collection, preparation, and management, so the way this is from a community reporting perspective, education, could be even citizen science. So
Mhm.
where where do you see this growing data dependence and the relevance of Python? Because Python definitely is a tool inside the data analyst toolkit, and a lot of people, a lot of academics actually generally would be on Jupyter. So this is a question that I'll pass back again to Carol. So where do you see us going in terms of data, maybe even a bit of machine learning as well? As I heard
Yeah.
fast AI just now.
Yeah, so I think it's a few different places. One is the concept of templating. And, there, like Audrey mentioned before, cookie cutter, there are data science cookie cutters out there. We've used some to build extensions within Jupyter and give the community like a platform to start from. But I think then there's other projects like Dataset that let you get into manipulating data in a much simpler way. And then there's been, much like many things in the Python community, other third-party packages that let you do portions of the data science workflow, if you will. Like PyJanitor, Eric Ma's project, actually will help you clean your data in a very structured, organized way. And where you had to do everything by hand and remember all the commands, now you can use that and feel pretty sure. So I think, the other thing with the Jupyter notebooks in particular with data is I view it much more as a communication tool than a computation tool. It's a communication tool that happens to do computation. And what it allows you to do is put prose and narrative in there so you can remember what you've done and share it with the next person. And I think it's sort of that organic sharing of, ideas that really is going to be powerful long-term for data analysis.
From an organic sharing of ideas. So taking this idea and putting it back to both Audrey and maybe Keith. Keith will be a little bit later on about data collection side, since we're also talking about embedded systems. But to Audrey, in terms of your in terms of your organic sharing and learning, perhaps you can relate this to a bit to your experience with PyLadies as well, in terms of or Cookie Cutter, when you're actually working on the development, the dev experience for Cookie Cutter Django or the standalone Cookie Cutter as well. How do you see this sort of sharing happen in terms of data when you're doing development for Cookie Cutter itself or the other frameworks?
So okay, there's a lot in that question. I guess one of the most common use cases of sharing data is where somebody has a particular data set that they've created or they've found, and they've done some analysis, and they just want to get it up on a website, a very simple website, as fast as possible so that they can post it on Twitter or social media and share it with the world. And in the past, people have said, "Oh, you should teach Django for data scientists," and I've always been a bit hesitant because I've felt like using Django and even using some of the cookie cutter templates out there for data science are a bit complex for someone who just wants to share some data in a few hours. They have a kid, they don't have time to figure all this stuff out, and And I've recently been playing with a couple of tools, Streamlit and JustPy. Both of them are Python packages that allow you to take you can take a pandas data frame and create a very, very simple website with Python and get it out there. And you know, I was just playing with it right before this, and 21 lines of code in JustPy of Python code allows me to create a web page, add a div element with a bunch of buttons to it, and provide handlers. So when you click on those buttons, you can do whatever. You can change your the data in your chart, and I think that you know, people have been attracted to Python because it's simple, because it's elegant, and the tools are evolving to go in this direction of more simplicity. That things have gotten very complex, and it's coming back.
Thank you very much. So
I hope so.
Now that we have the data aspect, so now that's like data entry, the templating, and so on. So now the question that I will pose to Keith is, since we do have a data entry component, and now if, let's say, we talk about IoT, let's not talk about IoT, let's talk about collecting data via small embedded systems, because that's what we do a lot with Raspberry Pis, even microbits on this end. So the idea here is, do you see also SNCC filling that niche, or some other framework that you also work with, as well as the SNCC board, when we think about it as well?
No, I think SNCC is a great gateway into learning Python. And once you have the basics of the language, using a more advanced version of the language like CircuitPython, which has the ability to connect to those sensors and do real data collection, and has internet primitives to upload that data to the internet, is a fantastic way to move forward with that project. I've taken many students from very basic robotics into advanced research, using the same robotics languages and the same robotics concepts, but kind of up-leveling them in their platform sophistication. So you move them from an Arduino to a Raspberry Pi, or you move them from an Arduino to a CircuitPython board. You can really get a lot more functionality without having to teach them a lot more computer stuff by starting them in Python and keeping them in Python. So SNCC is an early childhood education language. It's definitely not designed to do the kind of scientific data gathering. And I don't really want to take it there. I want to keep it so you can write programs in 2 lines of code and have your lights start blinking. I did want to note, though, that I have 2 interesting stories that are very, very much related to this. Teaching children Python is a gateway into their scientific adventures in further life. I have a young friend who is now has a PhD in science and public policy, was getting an undergraduate degree in astrophysics, and because she knew Python, she got to spend an entire summer at Arecibo, the radio astronomy observatory in Puerto Rico. She was the only one in her class who knew Python. She got to do the amazing adventure. So remember that Python is a gateway to fantastic adventures.
Gateway to fantastic. I'm sure we all agree with this. So this allows us to segue slightly also into a question that a viewer actually has, and he asked from Sui Meng. They asked, is Python going to be the basic of the 21st century? So you might be seeing this in the incoming comments as well, but will Python be the basic of the 21st century? What do you think about this statement? For better or for worse, I guess. It could be either way as well. Maybe I'll start. We'll just do a round table for this. Carol, it's back to you.
Okay, so BASIC was actually, I'm of the age where BASIC was the first language that I learned. I'm not sure that I would say Python would be the basic of the days today, but what I think Keith kind of hit on was that joy of exploration, that easily getting something running in a couple lines of code and seeing it in front of you. I know for me, very crude games with like, 8-bit square balls, single color, that was fascinating to me. And then when the first Apples came out, I have the fortune of using one, and I was in 7th grade, I think, at the time. And color just opened up this whole other avenue to explore. And I think, Python, whether you're a learner who's a child or coming back to work after taking some time off, or, just trying to help your grandkids learn how to do this, it's very accessible. And I think it's also fun. I think sometimes we overlook the fact that, to really be engaged with a topic, you have to enjoy it. There has to be some element. It's sort of like if you're learning to play a musical instrument. And in many ways, how you learn a musical instrument is how you learn Python. It's a gradual evolution where you're, working on things that are much more complex, where other people have written part of it, and then you're organically building some of the stuff from the ground up.
Okay, so organic building from the ground up. So next we have Audrey. Back to the question. The question being, is it going to be the basic of the 21st century?
So when I was around, I don't know, 8 years old, maybe, I learned my first programming experiences were with BASIC at school on a Radio Shack computer, and at home with Microsoft QBasic. And at home, I discovered you could draw, and so I drew a birthday cake, and then I figured out how to use the computer speaker to play Happy Birthday. And this was around Windows 3.1 era, and as a kid, I realized I didn't really like Windows 3.1. I thought I could make something better. So as a kid, you don't see bounds. You think, oh, I could make my own operating system. And so I made a menu that had all the things that a kid could do, that you could play the Happy Birthday, you could play Mad Libs, you could see flashy boxes all over the screen. And to me, that's what I equate using. That's my experience of using BASIC. I have a 1-year-old daughter, and I am so excited to teach her programming. And the question is, will I be teaching her in that? I probably will teach her drawing will be one of the first things I'd want to teach her on the computer. Also, robotics is very nice, but maybe might be a little bit older. I think her first experiences will probably be just, can you draw something? And with that, honestly, it's a toss-up of whether I would use Python or use JavaScript. I hope that that the Python drawing tooling will advance a bit. I find the Turtle library that's built into Python a bit in need of updating. I think I don't want to get into detail, but
it's good to hear.
So what I've really enjoyed lately has been playing with CodePen.io and using processing, the P5.js version of processing in CodePen. And what I love is that you type a line of code and it auto updates. You don't have to hit save. You don't have to hit shift return or whatever the Jupyter note. I can't remember what that code, what that keystroke. Yeah. You just type. As soon as you change the RGB values, you change the numbers around, you see the update happening instantly. And if we can, maybe there is tooling that does that in Python. I haven't seen it, but if we can get there, then maybe Python will be the teaching language, the basic of my teaching my daughter. But I don't know.
It's interesting you say that, Audrey, because a couple summers ago, I had to teach middle schoolers and high schoolers, like 2-hour workshops at Cal Poly on programming. And I did interactivity in visualization. And I started them with P5.js. And at the time, it had like an alpha browser for it. And it was amazing because I also needed it to be dual language. And then from there, the second half of the day, we explored Python, and in particular, Magenta, which is a machine learning program based on TensorFlow that lets you do art and music. And they were really engaged and really excited. So I think you're on to the right starting point, and I wish we had a Python version. So maybe somebody here will build one.
That would be
a challenge for everyone.
Yeah.
Okay.
Now you got me many more things to go play with now.
So I again, to pass the question, but I'm going to change the question a little bit because this is an add-on, so everybody can feel free to go in, but I'll ask this to Keith directly first. So there's an add-on to just the basic of the 21st century. So the idea is the basic of the 21st century will be ubiquitous, universal. Everywhere you get it, whatever platform. So Python's definitely on the way there. We see it running almost everywhere, embedded systems and so on. But do you see that, again, also becoming basic of the 21st century? Again, for better or worse?
Yeah, well, it would be a better basic than JavaScript is. And unfortunately, JavaScript is much more pervasive. And not to bash on JavaScript at all. It's a very valuable programming language, but it's much more complicated to teach than very simple Python. It's a bigger language that's harder for me to get my head around. But I started the SNEC project as a notion of getting back to how I learned programming with very, very short programs, no more than 2 or 3 lines long, that would teach basic programming concepts. And so a language where you can teach all of the basic programming concepts in the language by having program examples that are only a couple of lines long, that's a language that I love to teach to younger children. But we need to expose children to a wide variety of languages because different children have different learning styles. They have different physical abilities. And so languages that let you click and drag stuff are great for children before they learn how to use the keyboard. Languages that are focused on music and color and graphics are fantastic for children that have a very visual, artistic approach. Languages that have a lot of robotic stuff are great for children that love to build things with Lego. And so we need a lot of languages and children exposed to all of them to try to get an idea of how to teach them how computers work.
Okay.
But Python to me is definitely a language that everybody needs to have some exposure to who's going to be doing anything in the sciences or on the web or trying to build their own applications at home, because it can do everything, right? We have so much infrastructure for Python now. Everything from GIS applications to the Jupyter Notebook stuff, which is like Don Knuth's literate programming, gone live. So I'm excited to see how far Python has come and how much we can still do with it.
And taking that, how much to do with it, now I'm going to pass this question again. Where is Python heading off to right now? Because we've focused on education and the future of education and how we do sharing and a little bit about data. But so the question now that I'm going to pose back again to Audrey, and this is taking an idea from Keith, because Keith said different kids have different styles, I would think. You say that some will be involved in robotics, circuits, some want to do data, some find it they can't take that, but they do something else with Python or whichever language that comes to them. So the idea is, let's say in your organization, in your organizations and the teams that you work with, how do you get them interested when they may have very diverse ways of accepting the language or the concept they're trying to do in the language? Yes. One moment. There's also, So question, how do you get their interests when they have such a diverse set of starting interests? Because, I mean, they might be a guy who says, I want to do robotics, but the other person might go, I can't do robotics. I don't know circuitry and so on, but I want to do data. Or maybe another person, I want to do content management and so on. Is there a way that you can talk and get them at that level where they can learn Python?
Well, I would say the biggest thing is writing lots of small Python scripts instead of trying to create that one very ambitious Python project that does everything. That, you know, if that Python, the beauty of Python is that it's so simple to work with and there are so many libraries that do so many complex things so simply that that it's very feasible to write a new script every day that does a small thing. That like I know Dan, my husband and I have been doing some laser cutting stuff like earrings and designing those things. A Python script can be written that's very, very short that achieves a lot. And so having small scripts, small scope, and building up the knowledge from there.
Okay, there is an interesting question that was raised, and also here's the thing: we get a lot of there are some comments from the floor also that anybody can get a project running. Unfortunately, we also get a lot of beginners who think their code is good enough. So I think this is a natural issue in most languages, but Python kind of shortens the gap before you get there. There are lots of poorly written bits and pieces going around on Gist and so on. So how can we, and this is a future thing about Python, how can we prevent or minimize a future where Python is that oversaturated? This is the question that is asked. How do we prevent or minimize a future where Python is oversaturated with potentially weak programmers? Let me soften that a bit. So what do you think? Maybe now to Carol?
Yeah, I'm excited because I wanted to answer this question. You know, coding is often thought of as a solitary activity, but in reality, it has much more to do about teamwork and communication skills and learning from each other and sharing of knowledge. And in order to go from a beginning or junior programmer to a more experienced programmer, you need to continue to hone your craft. You need to learn how to write good tests. You need to, look at what a code smell is and where it's like, oh, maybe you should do it this way. One thing that's great is there's a lot more automated tools now to guide folks, but I don't know that they will fully replace working with other people that are at different levels than you in your coding journey. One of the things in the sciences, we often will have PhDs and postdocs trying to write Python code where their depth of Python knowledge is actually fairly shallow. And so what the Carpentries, which is a nonprofit around the world, has done is they've put together best practices on how do you write a project and productionize it. And I think, to really prevent the oversaturation with weak programmers, you need to instill a love of programming as well as a curiosity and build as much problem-solving skills as possible, because languages will come and go, not as quickly as people think. I mean, C is still around, BASIC's still around, Python's now 30 years old. But I think that's the difference from being a junior or just starting. And for some people, that is all they will ever need. But other people will want to go further. And we should encourage and give them the tools to do so.
So in this term, you propose it would be collaborative, that this future of preventing bad code would be indeed primarily driven by person-to-person collaboration, stuff like GitHub and so on. Does everybody see this similarly as well, working with everybody else as well? And beyond this, perhaps a question I can put to Keith as well. I'm certain SNEC, in its being based on Python, you also try and have its same elegance as well. Do you take any steps to at least ensure that the people who start with SNEC also get a good grounding into the world of Python itself?
Probably not. SNEC is a very small language. Imagine Python 1.0. It has a lot of the same structures as that very early version of the language. So it doesn't have objects. So one of the core features that we use in kind of real Pythonic programming is the notion of objects and methods and using that functionality. But that's very difficult and a very difficult abstraction to teach to a 10-year-old child. But in terms of Carol's notion of using mentoring, one of the things that the instructor that runs the program that I'm a part of, she actually we teach children from about 10 to 12 in this class the programming aspects of robotics, but she has students who have graduated from the class from ages 13 to 18 or so come in as mentors teaching the children. So we have adults helping teach the mentors, and then the mentors actually teach the students one-on-one. So we're teaching the older children how to teach and how to teach programming. And so we're trying to build a culture of continuous education, continuous learning, and the process of learning through teaching, and the notion that one of your roles as a senior student is to teach people who are not as experienced as you.
That's quite interesting as well, to take the concept of that mentoring as well. Thank you for the word, by the way. It temporarily slipped my mind. So about the mentoring, we actually do this locally as well, as in like train the trainers, and then it slowly goes out and spreads out. So here's an interesting thing. Since we're on this topic, and we always talk about code refactoring, and just now Carol mentioned code smells and so on, right? So one of the things that we try and teach, but it's very hard to teach, is optimization. And in fact, a lot of, I would say, academics these days, they don't understand the concept of optimization, because for some of us who began programming in the earliest days, we didn't have a lot of RAM. For example, I started on a Commodore 64, and that's 6502 chip, learning on BASIC and so on. So the question is, how do you teach optimization? How do you teach optimization in terms of coding, how to refactor that code smell? So I'll put this question to Audrey.
Sure. So the best way, in my opinion, to teach optimization is to gamify it by providing metrics. So profiling your Python script, or if you have a web page that is running slow that you want to optimize and run faster, you use the Django debug toolbar or similar utilities to see why it's slow, and Chrome DevTools, and just keep getting those numbers down. See how many SQL queries are going on behind the scenes to the ORM, and can you reduce that number of queries? Can you write better queries? And just teaching people to rely, that then you don't have to nag people that, hey, this is slow. And these tools are good also for, there's going back to the point about writing low quality code. There are tools to automatically check for code style and code smells and common anti-patterns. There are a lot of Python packages out there for these things, and there's also SaaS services. So relying on some of these tools.
Right. We are coming towards the end of the session already, but I'll just go one more round table just in case. Is there anything, maybe Carol or Keith, you'd like to add about that training optimization before we go through our last round table to end the session as well?
I think Audrey, go ahead, Carol.
Yeah.
Well, I was going to say, I think everything that Audrey said is spot on. The one thing I might add is write tests. If you write tests, it will be far easier to refactor and to do these code optimizations that, especially if you're out in production, because you don't want to bring down something that is working well because you've neglected something.
Keith, anything to add as well, or
I can't do anything but amplify what Carol and Audrey have said. Audrey said we should use automated tools and we should measure before we try to optimize.
Mm-hmm.
And Carol said we should write tests to make sure that when we refactor and optimize, we don't break anything. So yes, those are fantastic suggestions.
Yes, I would also, any suggestions, by the way, from anybody about the test packages that you would recommend actually for beginners or who are willing to get started? There are lots of people who don't write tests. Any place where they can get started? Testing frameworks?
You want to start, Audrey? Audrey, you want to start?
Well, Python has unit tests built in, and PyTest is also very, very good. And then if you want to get fancy and have some fun with randomizing the input values that go into tests, you can use Hypothesis. Mm-hmm. And then Faker is good for generating random data for tests.
Okay, so more or less we have about 6 minutes left. So I guess we're going to summarize things right now. So right now we're going to talk about your long-term outlook. And this one is the projects that you've been working on, not necessarily the projects you work on. What are those promising projects you've seen, and what paths do you think these projects may take in the next few years? And if you like, you can throw in also the overall direction of the Python language as well. So once again, I'll go reverse roundtable this time. One more time, Audrey, so I'll go through to you as well. So Audrey, where the most promising projects you've seen, not necessarily ones that you worked on, and the direction the language is going. What do you think?
Well, I think that I'm very, very excited about the Python web world, and particularly, I mentioned some of them. Anvil, JustPy, Dataset, which Carol mentioned, is so exciting. You know, taking a SQLite database and being able to suddenly see the data on the web and expose, use any of their plugins. Like there's a GraphQL plugin, for example. Those are the Streamlit's also exciting.
Okay. Keith, maybe on your side, where do you see all of this going to, and the packages on the projects that are most promising that you see in the next few years?
Well, for embedded programming, certainly CircuitPython is a rising star in embedded Python programming there. Adafruit has put an enormous amount of effort into building educational materials and building a good ecosystem with hardware and software. That's a fantastic opportunity for people to do low-level embedded programming without having to dig into C or try to do custom stuff. That's a great environment. On top of that, there's a fantastic, easy-to-use Python editor called the Mu editor that drives all these embedded devices. It also allows you to explore with Python in a desktop environment. It's a very easy-to-use editor. It's very approachable. It's very Python-centric. I've really enjoyed working with the people in those two projects a lot.
Thank you very much, Keith. So, what about you, Carol? Where do you see things going in the next few years, and the outlook of the language in general?
Well, I think the outlook of the language in general is very positive and very exciting. I think oftentimes I'll give talks, and what's really hard is there's so many places that Python is used. It is hard to kind of cover it in one talk.
Yes, it is.
Yeah.
And which is great, because we have a strong community that can do that far better than I could do justice to it. But I think, a lot of times folks will focus on performance and, this one, runs this much faster than the other one. And going back to what Audrey said about metrics, it's like, okay, but what metric are you using? Are you looking at how quickly you can code something and get it into production? Python probably is the winner there. Are you looking to maintain it long term and have people be able to read it? Because far more code is maintained than written new. So being able to read code is really important. And And I would challenge those that think, oh, you just need to get the code out the door. Oftentimes, you can pay now or you can pay later. Each time you don't write a test, you are adding time to whatever the next thing you're trying to do is, because you have no ability to know what breaks when you change it. And this is even if you're in a startup writing brand new code, it's really important. You don't have to have 100% test coverage, but you should be aiming for 50% or higher. And in the short term, I mean, I just think Python growing globally is so amazing. And, you know, I've traveled the world and seeing people who are doing amazing things, and a way to share that is something that I really hope the Python Software Foundation continues to focus on.
And with that, thank you very much, Carol. I got one last question. It's a yes/no question. This is actually just to Keith. Keith, somebody asked, would you suggest SNEC or CircuitPython for the novice? Can they try that?
Well, one of the nice things about SNEC and CircuitPython is they can both run on much of the same hardware. So you can try both. And that's a fun thing to try. If you already have an Arduino board, you can install SNEC on that and give it a try. If you have a larger board from Adafruit, you can try both on many of those as well. So I would encourage you to get a board that runs both and play with them both.
Oh, okay. And with that, I guess we're currently out of time, but Keith will be on again later, I believe in 5 minutes time, which is why.
Oh, wow.
Well, thank you so much, everybody, for your time and for speaking about the future, the patterns for the future for Python. I think it's been really interesting. We've seen collaboration. We've seen the frameworks you work with. We've seen how it applies to education, a little bit of data. Some might say it's a bit over the place, but then again, that's the nature of Python. Everything goes, and it's really interesting to hear it from all of you as well. So thank you again so much, Carol, Keith, and Audrey. Thank you so much for your time. And let's all give a wave to the camera as well, in case anyone. Yeah. Thank you so much, also, viewers.
Thank you so much. Good to meet you.
Microsoft is delighted to be at PyCon.